Hello everyone. This is a short presentation on effect of different sequence distributions on ISI in an MCvD system. The work has been done by myself, Tamogno, Dr. Krishna Gopal Banerjee and Dr. Adrish Banerjee and has been accepted in SPCOM 2022. Now the problem that we are going to discuss here is to reduce the effect of ISI in an MCvD system. And to solve this problem, we first need to answer a few questions. First one is, why is ISI a major issue in an MCvD system? And what are the factors behind this ISI? And let's come to the system model of an MCvD system, where there is one point transmitter that actually releases the molecules in the environment and they propagate through the diffusion process and then finally gets absorbed by the receiver. Now it has been seen that if the point transmitter is transmitting 100 number of molecules to represent binary bit 1 in an on-off ring modulation, then only 9 to 10 molecules actually gets absorbed by the receiver. These remaining 90 molecules cause a huge overhead for the next symbol transmitted by the transmitter and causes the ISI. And this picture has been depicted in another figure that is ISI effect on subsequent bits. Now for any n-length sequence with a channel memory L, the expected ISI of the ith symbol can be given by the equation 1 for both the uncoded case and an NS code. Now, the expected ISI for an NS code is actually dependent on the two parameters. First one is Pi minus K plus 1. That is the absorption probability of a molecule in the I minus Kth interval. And another one is the sequence distribution, that is CK. Now, this probability of error is actually proportional to the expected ISI on the ith interval. That means if the ISI increases in the system, then the system performance degrades. Also, this expected ISI is proportional to the weight of the sequence and also the bit 1 locations in the sequence. For any constant weighted code word, we can actually classify the sequence distribution into broadly into 4 categories. First one is ones at starting positions, that is OSP sequence. Second one is ones at end positions, that is OEP sequence. Third one is ones at middle positions, that is OMP sequence. And finally, ones at start and end positions, that is OSEP sequence. Now, all these 4 types of sequence distributions can be generated by the beta distribution function that has been given below. Now, the probability of generating the ith bit is PRI, that is P of x equals to y, where x is the random variable and I is the discrete integer from 1 to n. Now, for a very small value of epsilon, typically in the order of 10 to the power minus 2, it has been seen that PRI is, if PRI tends to epsilon, then the ith bit of the sequence is most likely to be 0. And this position is defined by n dash and is given by the equation arc minimum I of PRI minus epsilon such that I equals to 1 to n. If we solve this equation by the Newton-Raphson method, then we'll get two solutions, n1 dash and n2 dash, and they typically lie between the range from 1 to n. So let's come directly to the OSP sequence, where most of the bit ones lie in the foremost positions of the sequences, where n1 dash is 1 and n2 dash is much less than n and can be generated by this following effects. Now, OEP sequence is just the reverse of OSP sequence, where most of the bit ones lie in the inmost positions of the sequence. And for both the sequences, the figure has been depicted. Now, in OMP sequences, most of the bit ones lie in the middle range, where OSCP sequence similarly is just the reverse of OMP sequence. Now, if we directly look into the simulation result of the expected ISI, it can be seen that the OSP sequence gives much better performance in terms of ISI than all other sequence distributions, and also the previously illustrated codes in the molecular communication. Now, so far, ISI mitigation code has given the best performance, but it actually considers the constraints such that there should not be any consecutive bit ones while constructing the codes. Also, the sequence should start with the first bit 0. But in our case, OSP sequence, there are not such many considerations, and it also allows the bit 1 until a certain positions in dash. And we are also interested in constructing the codes, not only the construction of sequences, so the maximum number of possible sequences with weight omega c can be given by the following equations. Thank you.